Thanks, Mehmet. So, Mehmet has introduced mdspan, and let's get our hands dirty immediately. So, I hope everyone is logged into Lumi. If not, please do it right now. Again, you can SSH into it and use your favorite text editor, or like me, just use the VS Code provided by Lumi. The reservation for today is ENCCS day 2. So the day 1 reservation is gone, but don't worry, you can still work on everything we were doing yesterday. It changes nothing. Again, the number of cores requested is 4, 2 GB of memory is fine for me. 1 GPU node, and I've set 8 hours as the time for my session. And we can just launch. Wait for it for a second. And there we go. So we opened the folder we were working on yesterday. If you set up according to what we did, so it's probably inside your source directory, and then Alpaca workshop slides. Since we left over some work from yesterday, we continue with day 1, and we go to using mdspan. Over here, you can look at the README. It tells you what we need to do. It says we need to change the heat equation CPP. So this would be where we passed in our pointer and pitches from. And we need to edit stencil kernel. So this is where we will use the mdspan. For those of you who are properly awake by now, you might notice that we also passed the pointer and pitches to initialize buffer kernel and also to the apply boundaries, but we've already changed that for you, so you don't have to worry about it. As a colleague of mine calls it, this is a simple copy-paste job or a monkey job, so you can think of this more as a warm-up. So let's get into it. Editing heat equation. So going to line 92, you see that we have some instructions here that we need to start using mdspan. And we need to do this in creating the work division, in executing the kernel, and in apply boundaries. What we can do with mdspan, as Mehmet introduced, is get rid of the pitches, because it's a small wrapper container which holds your pointer and the pitch together. So you can directly get rid of these things. Oh, that feels good. So if you want to take a peek, you can look at, for example, the initialize buffer kernel. This is what we have already edited. Over here, you can see we are now passing the ACC. Of course, it is passed to all kernels automatically. And now we pass an mdspan and dx and dy. So no more pointer and pitch, and instead we just pass the mdspan. The type of the mdspan, as Mohammed already said, is a templated type. This is because the actual type of the mdspan is somewhat complicated to write out. So this is what we do for convenience. So maybe we can start by looking at how we can pass in this mdspan to initialize buffer kernel. So for those of you who already have the cheat sheet at hand, can you please tell me how can we get a mdspan for a buffer? Any hands? Klaus.
With get mdspan.
With get mdspan. Beautiful. People online, you're missing out today since I have some sweets. There you go. Sorry. So we use get mdspan, and the point is now that we can do that, we can get rid of our buffer.data and pitch. So I do this, and instead just alpaca experimental get mdspan. Is this how it is written? So this gives you the mdspan, and that's basically all there is to it. So now we need to make this change everywhere else as well. So I'm going to be copy pasting a lot. So this is where we passed the kernel arguments to workdiv. If you remember, there is some code duplication, and we need to do this as well where we execute the kernel. So I do that. So just to check, yes, I'm doing things correctly. So what's next? I need to do the same thing for my core work division inside stencil kernel. But before we do that, it might make sense to look at stencil kernel HPP, since this is something we have not edited yet. And we need to use mdspan over here. So how do we do it? Of course, what I want to do is get rid of the pitches and the pointers and replace them with mdspans. So let's just do it. What's the type of the mdspan? Well, it's some complicated type that I don't want to deal with. So I just call it the mdspan for right now and say, okay, this is the span for current buffer. Similarly, I can do span for next buffer. And once I have these, I can just get rid of my pointers and pitches. Of course, we still don't know what this type is, but like good C++ programmers, everything can be solved with templates. We just define the type here. And that should be it. You don't have to pass this type manually. It will be deduced by the arguments you pass, so nothing to worry about. The next question is, what happens to my, okay, I passed the mdspan. How do I use it? How do I used to pass the pointer to get element pointer. I used to pass the pitch over here. So how does this really improve my life? Well, the answer is you can access the buffer elements using mdspan how you would expect to access a 2D array, quite similarly. And I will show you the syntax for this. So for example, over here, I was trying to get the element of nextBuff at global index. I can do this by saying I take the span and simply access it using the round brackets at global index 0 and global index 1. So this is what you get from using mdspan. You're able to get rid of this ugly function we wrote, and we don't have to use pitches anymore and can directly access elements using like this. And there you go. Yes?
So here we put like y and x in the parameters of the span.
So yes, the mdspan it's changing nothing in terms of the data layout. So you pass in arguments in the same way as you would any other place.
Yeah, actually, mdspan has a layout parameter, and you can install. You can make it row major, column major. Alpaca is using row major. You can also embed padding or pitch into this layout, and this is done by automatically get mdspan function, which is managing this row majorness and the padding.
So yes, as was mentioned, this is in the Alpaca experiment. Oh, Brian.
We still need to dereference mdspan.
A very good question. The question was, do we still need to dereference over here if we're using mdspan? The answer is no. We are no longer dealing with pointers, so we can just remove this. To simplify, I can move all of this over here.
Otherwise it should be a reference. Otherwise an element should appear a reference.
Yes.
The data is copied, mdspan is given the value.
So the nice thing about this is you no longer have to define all of these and do this math, which we were struggling with yesterday and is still broken over here. But thankfully I can just remove it. So
There's a comment in the chat that you removed the constness for the current buffer here in mdspan. Is it on purpose or?
no, it is not on purpose. This is a good point.
Before it was const pointer, and now you make it non-const. Should be visible const. I think you missed all.
So that would make it const. Yes. Thank you for pointing that out. So we do the same thing. We replace get element pointers everywhere else as well. We use our mdspan. So this one was our global index. And now, for example, I'm going to replace the right. So this is simply adding 1 to the x index. Next, we replace the left. This is simply -1. Down. +1. And up. -1. And that is how mdspan can simplify your life inside the kernel. Again, just simply pass the mdspan and use it like this, using the round brackets. Now we need to make some changes over here, since we have modified how we pass things around. Again, we use get mdspan. We can remove our pointers and pitches. We get the mdspan for the current, for the next. Yes, that is named correctly. Current, next, halo size dx dy dt. Current mdspan, next, halo dx dy dt. And again, we changed this in the work division, so we need to copy this to the exec as well. We do that. We need to make these changes also for apply boundaries. So I make the change over here. Instead of the data and the pitch, just the mdspan. It's a copy paste job. And I think that should be it. We've changed, we are using mdspan to create the work divisions, to execute the kernel and in apply boundaries. And we've also changed the stencil kernel to use mdspan. Let's try to execute it. So, of course, remember to source your profile, everyone. Load the modules you need. If you are not on a compute node, get on a compute node and compile over there. And we go into day 1 for using mdspan, go to the build folder and run cmake. Now, Mehmet mentioned how you can enable using mdspan using the cmake flag. You can do the same thing inside ccmake. We enable our GPU. We go down, and over here you have the setting alpaca use mdspan. This is setting the cmake flag. We need to change it to fetch. So we do this because mdspan is currently C++23. So we are using the alpaca mdspan, and you can get it like this. We configure. And I am missing a bracket somewhere. 120. Similarly here, sorry about the missing commas. And you can execute. This is how you can use mdspan to simplify your life. And you can verify at every step if your results are correct. So that was our warm-up session. I hope people are now energized and ready for the things ahead. So now we move on, unless someone has any questions.
Question?
Yes.
So can we use swap on the mdspans as well?
Yes, you can use swaps on the mdspans as well.
mdspan is not owning the data, it's only pointing to the data.
So the comment in the room was that the mdspan doesn't own the data, it only points to the data. So something like swap is completely fine to do. Okay. So now Mehmet will continue with our next session.